Have you noticed that some new phones now squeeze 7,000 mAh batteries into bodies that do not look much thicker than last year's models? That is not clever marketing alone. A quiet change inside the battery is making room for more energy. The technology is usually called a silicon-carbon battery, but the name can be confusing. This is not a completely different battery like solid-state. It is still a lithium-ion battery. The important upgrade is inside the anode, the side that stores lithium while the phone charges. Most phone batteries have traditionally relied heavily on graphite in that anode. Graphite is stable and proven, but it can only hold so much lithium. Silicon can store far more at the material level. Blend or structure silicon with carbon, and engineers can pack more energy into roughly the same physical space. That higher energy density is the reason a slim phone can suddenly advertise a much larger capacity. The manufacturer can use the extra density for a longer-lasting battery, a thinner design, or space for cameras and cooling. It does not mean the battery has become magically weightless. It means the same internal volume is being used more effectively. There is a catch, though. Silicon expands substantially as it takes in lithium, then contracts when the battery discharges. If that movement is not controlled, particles can crack, electrical contact can weaken, and capacity can fade. Modern silicon-carbon designs use tiny silicon particles, carbon structures, special binders, protective layers, and careful charging controls to manage that movement. This is also why two phones labeled silicon-carbon may not age in exactly the same way. The amount of silicon, the cell design, temperature management, charging speed, and software limits all matter. A bigger number on the box tells you capacity, not automatically safety, lifespan, or real-world endurance. And milliamp hours are only part of battery life. Screen brightness, modem efficiency, processor design, software, and signal strength can make one phone with a smaller battery outlast another with a larger one. Watt-hours and independent runtime tests give a more complete comparison than capacity alone. So why are huge phone batteries appearing now? Silicon-carbon anodes have moved from laboratory promise into mass-market products, and manufacturers are learning how to control the material's expansion. The result is not a miracle battery. It is a practical upgrade to familiar lithium-ion technology, and it may be the reason your next phone lasts longer without becoming a brick. When comparing phones, look beyond the biggest number. Check real battery tests, charging temperature, long-term support, and the manufacturer's stated capacitor retention guarantee. The chemistry matters, but the engineering around it matters just as much.